Hello and namaste to the new video of Learn with us. In this video, we'll continue our second order linear differential equation series. Now, in the first part of this series, we have discussed how to solve the second order linear ODEs, which are especially constant coefficient and homogeneous one. Now we'll deal with the second order linear ODEs. They are constant coefficient, but in this case we'll have the non-homogeneous equation. Non-homogeneous equation means you have the function fx in your right hand side, and to solve this equation you have to determine the two type of solution. The first one will be as a complementary function. Then to determine the complementary function, you will use the similar process you have done for the homogeneous equation, and the next will be you have to find your particular solution or particular integral on the basis of the forcing term. This fx is called the forcing term. Okay, let me show you how to do this one. So generally the non-homogeneous solution, they are actually the summation of the two solution. They are, one is the complementary function and the next will be your particular integral. And to determine the complementary function, you can simply solve this non-homogeneous equation considering it as a homogeneous one. For example, first you will just put this fx is equals to 0 and solve for this, and whatever you have the solution you will call it as a complementary solution. But this is not the final solution. To get the final solution, you still have to find out your particular integral. So this will be the first part. In the first part, what will you do? You will first find out your complementary function, and after that, on the basis of the forcing terms, you have in the right hand side, and you will calculate your particular integral. This particular integral will have the similar nature as that of forcing term. If you go to the single processing, then this particular integral is your steady response, and your complementary function is the transient response. Okay, so the simple method to solve this type of non-homogeneous function is to find yc from the auxiliary equation, in similar we have done in the homogeneous part, and choose the trial solution for the yp on the basis of your fx, and substitute this trial solution in the given equation and solve for the trial solution. Okay, I'll show you. So to get the two assume your trial solution, you have to assume trial solution on the basis of the forcing function. I will come to this table later. Before that, let me give you one example. So you have your first example here for the non-homogeneous equation. You have second order, right? This is second order. This is constant coefficient. This is constant coefficient, second order, but this time we are solving the non-homogeneous. We have the non-homogeneous sum. This should be only the function of x. Okay, this should be only the function of x, non-homogeneous solution. Now to solve this, you have to calculate two solutions. One will be your complementary solution and the next will be your particular integral. First we will discuss about this complementary solution, and once this is completed we will discuss about particular integral. So to get the complementary solution, now just put this 4x square is equals to 0 and solve it as we have done in our first part video. If this is equal to 0, this is homogeneous. This can be solved by using the auxiliary equation. You will have your auxiliary equation m square minus 3m plus 2 is equals to 0. Your m will be 1 and 2. That means your solution will be y equals to c1 exponential x plus c2 exponential 2x. But this is not your final solution, right? This is just your complementary solution. When still you have to calculate your particular integral. Okay, you have already got your complementary solution. Now to get the particular integral, just look at your forcing term. You have the forcing term 4x square, and on the basis of this forcing term you will consider your trial solution. So now let's go back to our this table. So if your forcing term is just a constant, then your trial form for yp will be a constant, and you will find this a on the basis of the equation. Okay, and if your trial solution is polynomial of any degree, then if your function fx is polynomial of any degree, then your trial solution will be also the polynomial of that particular degree. Okay, for example, if your function is x, then your trial solution will be ax plus b. Okay, if your function is 4x, your trial solution will be ax plus b. What if your function is x cube plus 2x? this is a third degree polynomial. That means you need to have ax cube plus bx square plus cx plus d. This is fourth order, sorry, third degree polynomial. Since this is third degree polynomial, the trial solution should be also third degree polynomial. So in our case we have x square, right? We have 4x square. This is second degree. That means your trial solution should be ax square plus bx plus c. This is your second degree trial solution. Now you will consider ax square plus bx plus c as your particular solution, and you will calculate value of a, b, c on the basis of given ODEs. Okay. Now your trial solution is yp equals to ax square plus bx plus c. Now you will put this whole everything, this trial solution, the derivative of trial solution, and also second order derivative of trial solution back into the ODEs to get the value of a, b, c. For example, your yp prime will be 2ax plus b. Your double derivative yp will be 2a, right? You'll put everything back into the solution because this particular integral should satisfy, because this is the steady state solution. Okay, this solution need to satisfy this whole equation, right? This should satisfy whole equation, because complementary solution, that dies off after the certain time, and only the remaining solution will be the particular solution, and that still need to follow your ODEs. Okay, so this should satisfy your given ODEs. That means putting back everything in ODEs, I will have 2a minus 3 times 2ax plus b plus 2 times ax square plus bx plus c is equals to 4x square. Now equating the coefficient in the left hand side and in the right hand side, you can find the value of a, b, and c. So to satisfy this equation, you have to compare your coefficient on the both side. Let's say in the left side, you will have for x square, I'll write directly here, you will have 2ax square for the coefficient of x square. For the x you have minus 6a plus 2b here, and other constant are 2a minus 3b plus 2c is equals to 4x square plus 0 times x plus 0, right? So that means this coefficient 2a should be equals to 4, equating the coefficient on the both side. This should be equals to 0, and this should be equals to 0, right? So we have the three equation. 2a equals to 4, that implies a equals to 2. A is solved. Now for b, minus 6a plus 2b equals to 0, minus 12 plus 2b equals to 0, that means b equals to 6. B is solved. Now for the third, 2a minus 3b plus 2c equals to 0. 2 times a means 4, 3 times 6 is 18, plus 2c equals to 0, that means c equals to 7. Therefore your y phi will be nothing but 2x square plus 6x plus 7. So your final solution is yc plus yp. Your yc is c1 exponential x plus c2 exponential 2x plus is your 2x square plus 6x plus 7. This is your final solution. Sorry, my bad. So this is your final solution. And remember one thing, your particular solution do not have any constant. Okay, your particular solution, it this should not have any unknown constant. Let's say this should not have any unknown constant. Everything should be known. But in the complementary solution, you may have the general constant there. Okay, so this is our final solution. Okay, let me discuss more examples also, because every time your forcing terms may be different and the scenario may be quite different one. So look at here, you have your ODEs. They are second order, linear, constant coefficient, but the homogeneous, and your final solution will be on the basis of this forcing term. First you have to calculate, you have to you need to know, like you need to know these are the solution will be the combination of complementary and the particular. The complementary is quite easy. Okay, to find the complementary solution, you can just assume this non-homogeneous function is a homogeneous, right? Assume this is a homogeneous and solve for this. You have m square minus m minus 2 equals to 0. This will give you m equals to 2 and minus 1. That means your y is equals to c1 exponential 2x plus c2 exponential negative f x. This is your complementary solution, complementary function. Now to get the particular integral, you need to have the trial solution, right? You need to have the trial solution on the basis of this exponential function. Since your forcing term is exponential, obviously the particular integral will be the same nature of your forcing term. That means it will also be the exponential one. So your trial solution, by looking at this table, if the forcing term is exponential kx, your trial solution will be a exponential kx. So in this case, our trial solution will be a exponential 3x, right? So now you have to find the value of a, because the particular integral cannot have any unknown constant, right? So to get the a, you know that this solution should satisfy this whole equation ODs also. So you can say your y double single prime is equals to 3a exponential 3x, your y double prime equals to 9a exponential 3x, right? So once you have this, you can put everything in the ODs. You will have 9a exponential 3x minus 3 times a exponential 3x minus 2a exponential 3x is equals to exponential 3x. This will gives you 4a exponential 3x equals to exponential 3x. That means 4a should be equals to 1, a should be equals to 1 by 4. Therefore your yp is nothing but 1 over 4 exponential 3x. Okay, so your final solution y is equals to yc plus yp. That means yc means c1 exponential cx 2x plus c2 exponential negative x plus 1 by 4 exponential 3x. This is quite easy. This is now easy. So that's it. This is the final solution. So what if you have the forcing term in the form of harmonic function, sine or cosine? So here everything is similar, just a forcing term is different one. So let's first discuss about our complementary function. To get the complementary function, you can just put y double prime plus y is equals to 0. That means your m square plus 1 is equals to 0. Your m will be nothing plus minus I. That means 0 plus minus 1 times I. Your alpha is 0 here. Your beta is 1, right? So its solution will be yc equals to exponential alpha x c1 cos beta x plus c2 sin beta x. This will gives you nothing but c1 cos x plus c2 sin x. This is your homogeneous solution, or let's say complementary function, or you can just say it as the homogeneous solution. Now to get the particular integral, you have your yp. Here the forcing term is sine 2x. That means this is the harmonic function, so your solution, trial solution, should be also harmonic. So harmonic means you may have sine or you may have cosine also. So looking at this table, if you have sine kx or cos kx, the trial solution will be combination of this sine and cosine, because sine is also harmonic, cosine is also harmonic, and combination is also harmonic, right? So you can just consider the combination of sine and cosine. Okay, so here you have the sine 2x. That means your yp can be a sine 2x plus b cos 2x. So this is your trial solution for yp. This is what you can have. Okay, now you can have a and b value and get your a and b value and finally get your yp. So to get the a and b, what you can do is you can just get the derivative of this yp. This will be nothing but 2a cos 2x minus 2b sine 2x, right? So again, if you get this derivative, then you will have negative 4a sine 2x minus 4b cos 2x, right? So putting this everything back to the ODEs, we have minus 4a sine 2x minus 4b cos 2x plus you have only y here. Y means this a sine 2x plus b cos 2x will be equals to sine 2x. That means you have negative 3a sine 2x negative 3b cos 2x equals to sine 2x. You do not have any cos 2x term here, right? So equating the term coefficient of sine and cosine, you have negative of 3a equals to 1 and negative of 3b equals to 0. That means b will be 0. There will be no any cosine term. Your a will be negative 1 over 3. That means your yp will be nothing but negative 1 over 3 sine 2x. Your final solution will be c1 cos x plus c2 sine x negative 1 over 3 sine 2x. That's it. So this will be your final solution for the given ODEs. Okay. So now if you have your combination of these two functions, either exponential kx and the polynomial, you can have just consider the polynomial of the same degree and multiply by exponential kx. And if you have like a product, then you can have the similar product in the trial function also. Now comes the important part, overlap rule, which sometimes may call as the resonance. Resonance means what if your forcing term nature, or let's say the forcing term is already inside the complementary solution. For example, if you have noticed in this previous example, you have your quadratic form, right? Your trial solution was quadratic, and this quadratic form was not inside the complementary solution. This was not inside the complementary solution, because you can complementary solution are actually like a solution of the modes mode also. If you are familiar with the mode and the mode shape or natural frequency, the complementary solution are the homogeneous solution are the solution of mode. And if you're forcing frequency match with your natural frequency, resonance occur, right? So that will be the different scenario I'll show you. So if you see here, your x here you have the exponential 3x, the curve of exponential 3x, but this forcing term is not inside the homogeneous solution. If you see your homogeneous solution, you have either exponential 2x or exponential negative x. That means the forcing term is not inside the complementary solution. No resonance occurs here. If you see here, you have your homogeneous solution is just a cos x and sin x, but your forcing is sin 2x. That means in this case also you do not have your forcing nature inside the homogeneous solution. You do not have this scenario. But if I try this question, there may be something different. Okay, if you see here, let me show you. This is the second order linear constant coefficient. Okay, non-homogeneous. So to solve this, you have to get the complementary, or let's see, homogeneous solution and your particular integral. For the homogeneous solution, what you can do, you can just consider y double prime minus 2y plus 1 is equals to 0. That means you will have m square minus 2m plus 1 equals to 0. You will have m minus 1 whole square equals to 0. This will give off you two repeated roots, 1 and 1. Since this is two repeated root, your yc will be c1 plus c2x. For this you have to watch our previous video. Okay, c2x exponential x. This means you have c1 exponential x plus c2 exponential x. Okay, now you have your forcing term exponential x, and here's the important part. You have already your forcing term. This forcing term is already inside the complementary solution. This forcing term is already inside the complementary solution, right? So here this is the case of resonance. Resonance means your forcing frequency match with your natural frequency, or you can say this is the case of overlap rule. And if the overlap rule means if your trial solution already appears inside the complementary solution, so to get the new trial solution you can just multiply your trial solution by x. Or if again if the similar case occur, then just increase one more x. For example, in this case, first your trial solution, first initial your trial solution will be a exponential x, right? This exponential x, or let's say this constant into exponential x, is already inside the complementary solution, so this cannot be your trial solution. Okay, your new trial solution will be a x exponential x, right? Just multiply this by x. Still this x exponential x is inside your complementary solution, right? So again you have to multiply it by one more x. That means your final trial particular solution integral will be a x square exponential x. This will be your final trial solution. Okay, now your trial solution will be yp equals to a x square exponential x. Now you have to get the value of a. To get the value of a, you can just put everything and its derivative back to the origin. To put this back to the origin, first you have to calculate your yp prime and yp double prime. Okay, let me calculate yp prime. This will be quite difficult here because you have to apply the product rule. Your a is constant. Let's take it out. D over dx. This will be x square exponential x. If you are familiar with the calculus and the chain rule, you can just directly get it by using the product rule. That will be a 2x exponential x plus x square exponential x. Okay, so again if we're gonna do the derivative of this one, you will have a outside, again d over dx, you'll have 2x exponential x plus x square exponential x. And if you are going to derivate this by using the product rule, you will again get, I can directly write this one right now. You have just, if you are not familiar with this one, just revise your calculus part. You will have 2x exponential x plus you may have 2 exponential x plus 2x exponential x plus x square exponential x. Here you go. So you already have your yp double prime, yp prime, and your y. Then putting this all everything back to your ODs, you can get a 2x exponential x. Let's say this 2x can be added, so I'll write here 4x exponential x plus 2ex plus x square ex. We'll have negative 2 y prime here a 2x exponential x plus x square exponential x. You still have this one plus a x square exponential x, and the right side you have just exponential x. So I think most of the things will be like they will be subtracted and be 0. Let's see here. You will have 4, this 4x will be, I think this will be subtracted with this one, this will be 0. We'll have 2 here, 2a x square here, this will be subtracted with this one and this one. So ultimately you may have here 2a exponential x is equals to exponential x. That means your a will be nothing but 1 over 2. Your a will be 1 over 2. So now your yp is nothing but 1 over 2 x square exponential x, and your final solution is c1 ex plus c2 x ex plus 1 over 2 x square exponential x. This is your final solution, and this is the case of resonance 2, or let's say overlap rule, and you have to be careful here. Okay, I think I will stop here for the non-homogeneous part. In the following video we'll discuss about the Cauchy-Euler's equation and how to solve the Cauchy-Euler's equation. Till then, stay tuned. Thank you very much.